Hi there, today we're going to continue looking at tangent ratios and finding angles. Here is our first example. Find the missing angle, give your answer correct to two decimal places. In our diagram we have a large triangle with two smaller triangles. In the smaller green triangle there is a length of 8 meters and an angle of 10 degrees. In the blue triangle we have an angle of alpha degrees and 12 meters as a side. To start this question we need to look at the green triangle. We want to find out the length of the vertical side that is shared between both triangles. We'll name that x. To find x, we need to use the tangent ratio. Tan theta equals to the opposite side divided by the adjacent side. In our green triangle, theta is going to be 10 degrees. The opposite side is 8 meters and the adjacent side is x meters. To get x into the numerator, we're going to multiply both sides by x. So we'll get x tan 10 degrees equals to 8. To make x a subject, we need to divide both sides by tan 10 degrees. We will then have x is equal to 8 divided by tan 10 degrees. We'll leave this as it is for now. In the blue triangle, we want to apply the tangent ratio. Remember, tan theta equals to the opposite side divided by the adjacent side. The acute angle we're looking at is alpha. The opposite side is going to be x, and the adjacent side is going to be 12. So let's substitute that in. So we'll have tan alpha equals to 8 divided by tan 10 degrees, and all of that is divided by 12. This will become 8 divided by tan 10 degrees multiplied by 1 over 12. 8 multiplied 1 gives 8. Tan 10 degrees multiplied by 12 gives 12 tan 10 degrees. We'll then have tan theta equals to 2 divided by 3 tan 10 degrees. To find alpha by itself, we'll do the inverse of tan. Make sure you press the shift button on your calculator. This gives 75.185. Our answer to two decimal places becomes 75.19 meters. Here is our second example. Find the missing angles in this rectangle. Give your answers correct to two decimal places. In this rectangle, we have the lengths of 10 meters and 22 meters. The missing angles are alpha and beta. In a rectangle, the diagonals are equal and they bisect each other. What that means is that they cut each other in half. Let's put that into our diagram. Let's first take a look at alpha. To find alpha, we need to look at this section of the rectangle. Let's apply the tan ratio. Tan alpha will equal to the opposite side, which is 10 meters, divided by the adjacent side, which is 22 meters. To find alpha, we need to do the inverse of tan. Make sure you press the shift button on your calculator. Alpha on the calculator gives us 24.443. Therefore, alpha is equal to 24.44 meters, correct to two decimal places. Next, we need to find beta. Using vertically opposite angles, we see that beta also appears in the second triangle. Let's take a closer look at that bottom triangle. The bottom triangle is an isosceles triangle. That means the base angles are equal. Here we can use the angle sum of a triangle to help us to find beta. Alpha plus beta gives us 180 degrees. This is due to the angle sum of a triangle. Two alpha plus beta equals to 180 degrees. To make beta the subject of the equation, we'll subtract both sides by 2 alpha. We'll then have beta equals to 180 degrees, subtract 2 alpha. Substitute alpha to be 24.44. So we'll have 180 degrees subtract 2 lots of 24.44. Therefore, beta equals to 131.12. Here's our last example. Find the missing angle, give your answer correct to 2 decimal places. We have a large triangle ABD. The given angle is 40 degrees. BC equals to 3 meters and AD equals to 5 meters. Let's first use the tangent ratio to find the length BD. Tan theta equals to the opposite side divided by the adjacent side. In the large triangle, the given angle is 40 degrees, so we'll substitute that for theta. The opposite side to 40 degrees is 5 meters. The adjacent side to 40 degrees in the large triangle is BD. To move BD out of the denominator position, we'll multiply both sides by BD. We will then have BD multiplied by tan 40 degrees equals to 5. To make BD the subject of the equation, we need to divide both sides by tan 40 degrees. We will then have BD equals to 5 divided by tan 40 degrees. We will leave that as it is for now. CD is equal to BD subtract BC. BD we found to be 5 divided by tan 40 degrees. And BC is given to be 3 meters. So therefore we have CD equals to 5 divided by tan 40 degrees minus 3. To find theta, we need to use the tan ratio one more time. Tan theta is equal to the opposite side divided by the adjacent side. In triangle ACD, the opposite side to theta is CD. So we'll substitute the opposite side to be 5 divided by tan 40 degrees, subtract 3. The adjacent side to theta is 5 meters. To find theta by itself, we need to use inverse tan. So we'll have inverse tan of 5 divided by tan 40 degrees, subtract 3 in the numerator, divided by 5. Our answer to 2 decimal places will be 30.62.